factor. Gauge factor is ratio of it is basically sensitivity of the strain gauge. So it is a ratio of response to the stimulus. So denominator, this is your strain, and this is your fractional change in resistance, that is your response, and it is equal to whatever you see we have written here. It is your gauge factor is having three terms. First one is because of the that it is because of the change in length, and it is because of the change in area, and this is because of the change in resistivity. This particular term is not significant in case of metallic strain gauges. This change in strain change in resistivity or property of the material with the strain is not very much pronounced in case of metallic strain gauges, but it is significant in case of semiconducting strain gauges. So, and the phenomena which basically when we strain the material, which and it affects the resistivity of the material, it is called piezoresistive effect. So this is all we have done and we have discussed. Then what is piezoresistive effect and other things are concluded here in this slide. Then I ask one question, that why does metallic strain gauges are preferred over the semiconductor strain gauges? As you can see that from here, the semiconductor strain gauges are better because they are more sensitive in comparison to metallic strain gauges, because in metallic strain gauge this term is neglected because it is very small. So this will define, only these two terms will define the sensitivity of the metallic strain gauges, but semiconducting strain gauges will have this term also. So obviously the gauge factor or the sensitivity of the semiconductor strain gauges will be more, and this is a desirable attribute. So why metallic strain gauges are, despite of the semiconducting strain gauges having more sensitivity than the metallic, but the metallic strain gauges are you'll see in field that they are more preferred. Why? This question I had asked you on the last turn also. Any idea? How many of you are here? 14 people had joined. Not exactly 14, less than that. जी बताइए, any idea about this? Any guess? Idea or guess? Semiconductors are basically very sensitive to temperature. So the change in resistance will take place, even your strain remains same, your change will take place because of the temperature, if there is any temperature variation. And it will be more than whatever resistance change that will take place because of the change in strain. So because of although this kind of, temperature dependence is there in metallic strain gauges also, but it is not that much. So that's why metallic strain gauges are preferred over the semiconductor strain gauges, because because in any sensor we want that the sensor should be this is a requirement, that sensor should be sensitive to the parameter. Most desirable situation is that your sensor should be sensitive to only the parameter which we want to sense or measure, and it should not be sensitive to the other parameter. So here you see that the material which we are using, if it is using to make a strain gauge, if it is semiconducting material, then it is sensitive to the strain, as well as very sensitive, more than whatever it is sensitive to the strain, it is more sensitive to the temperature. And because of this reason, your semiconducting strain gauges are not preferred. I'm not saying it is not used at all, but it is not preferred. Metallic strain gauges are preferred over the semiconductor strain gauges, because semiconductor strain gauge is dependency of semiconductor conductor sensitivity, rather you can say, of the semiconducting strain gauges to the temperature, more sensitive. So this is the reason. I hope that I will be able to convey the reason
Yes,
to.
sir. Understood, sir. Understood.
Then you solve this problem in the last turn. If anybody is having any question regarding this problem, this question, this example, you can ask, please. Anyway, now I'll discuss the strain signal conditioning. As I think signal conditioning is basically, um, I would speak a little bit on the signal conditioning. Uh, as far as the instrumentation systems, as I told you earlier also, that instrumentation system is basically a sensor-based measurement system, and it is a multi-stage system. It is a multi-stage system. Means it will have many parts, but the starting part is always sensor, or a sensor is an integral part, and then we are having means the first part will always the sensor part. So this sensor part will obviously sense the parameter which we want to measure, and then it will give some other parameter, suitable parameter, which will facilitate the measurement, accurate measurement rather. Now this signal, whatever we are getting from the sensor, it require, finally we are having a display, or we are having a recording, or we are having an analysis. Suppose this is the final stage, final. So this ultimately this particular signal will be interfaced to it. This signal may not be suitable to be interfaced here directly. So we require intermediate stages, and these stages are called signal conditioning stages. So generally, you'll find that the instrumentation system will have sensor and signal conditioning stages, circuit, and then final output stage, any display like or something like that. So this signal conditioning is an integral, like sensor is an integral part of the instrumentation system. And what is the objective of signal conditioning circuit? The objective of signal conditioning circuit is to make the signal, measurement signal, suitable for the next stage, suitable for the next stage. Now suppose I'm talking about the um, strain gauge. So this is your strain, we are applying the strain and we are getting resistance. But this signal we want to feed into finally A to D converter to digitize the, so that we can interface to the computer. So now I want that all of you should imagine, and or you should figure out, rather than you should figure out, how can we convert our strain gauge output signal suitable to be interfaced to the A to D converter. जी बताइए. One thing is obvious, that whatever signal we are getting out of strain gauge, it cannot be given as an input to the A to D converter. Are you agree with me?
Sir, please repeat the question. I
सो रहे हो तुम लोग यार. What I'm saying, that strain gauge, the sensor is strain gauge, and we want to sense and we want to measure the strain, obviously. So when this strain is applied to strain gauge, then strain gauge resistance will change. So the in response to the strain, we are getting resistance. Hmm? Now the finally what we want, that whatever strain we are measuring, we want to convert it into the digital number and then it interface to the computer. ठीक है? Now I want, how can we convert this resistance into a signal that will be suitable to be given to A to D converter. So whatever circuits you will use in between to convert this output of the strain gauge into a suitable signal which can be interfaced with the A to D converter, these circuit will called signal conditioning circuit. What kind of conversion or change we require, that I am trying to find out through you.
सर एनालॉग सिग्नल के लिए उसको करंट में जैसे जो भी गॉज स्ट्रेन गॉज होगा वो तो रेजिस्टेंस वैल्यू देगा, तो डायरेक्ट एनालॉग सिग्नल उसको कन्वे नहीं कर पाएगा, तो उसको करंट सिग्नल दे सकते।
ठीक है, और कोई भाई? गुड, गुड that you are responding. Other people, can anybody refine his response? So basically, we want to convert. One thing is clear, that this resistance should be converted into the analog voltage, because analog voltage is given as an input to the A to D converter. So first of all, this resistance should be converted into the voltage. How can you convert resistance into the voltage? Easiest way, if you are having a variable resistance and whatever resistance change you are making in that variable resistance, you want to convert it into proportional voltage. How can you do that?
Sir, by passing a current.
Yes,
Sir, by passing a current through it.
by passing the current. अच्छा, कैसे पास करते हो आप करंट? कोई कोई
Sir, we will
सर्किट
make
तो
a
होगा ना?
circuit. Sir, we will make a circuit, sir.
कैसे बनाओगे सर्किट?
Sir, strain gauge का circuit.
कोई पूछ तो रहा हूँ, ये स्ट्रेन गेज, बस स्ट्रेन गेज लोगे उसमें करंट पास करा दोगे? करंट अच्छा कैसे पास कराओगे स्ट्रेन गेज में?
Sir, हाँ सॉरी सर, नहीं पता था।
क्यों नहीं पता? आप तो सिक्स सेमेस्टर में है, थर्ड ईयर में है। एक सिंपल सी बात कही जा रही है कि आपके पास सपोज है वेरिएबल रेजिस्टेंस, इससे सिंपल सर्किट नहीं हो सकता।
हाँ सर, सही
तो
बात है।
यू शुड अप्लाई योरसेल्फ। और आप तो सर्किट पढ़ चुके हैं, बड़े बड़े सर्किट सॉल्व किए हमने। व्हाट इज द प्रॉब्लम?
सर आप सीनियर टीचर हैं ना, थोड़ा डर लगता है बोलने में।
अभी तो हम आपको कुछ कह भी नहीं सकते, है ना?
नहीं
मतलब
सर, कह नहीं सकते सर, आप सीनियर टीचर है तो बोलने में
आप
भी
अगर
डर।
कोई चीज बताएंगे तो वो कोई डिसरिस्पेक्ट नहीं होगा टीचर का। ठीक
ओके
है,
सर।
हम तो चाह रहे हैं आप बताएं, आप पूछें। आप कोई और भी बता सकता है, या आप भी रिस्पेक्ट में कुछ नहीं बोलेंगे? The easiest way, as just now, whoever, I am not able to recognize him, um, it was correct, but how it is done? So generally a voltage divider circuit is made, है ना? इस टाइप से कर लेते हैं। एक वोल्टेज डिवाइडर सर्किट बना लेते हैं और यहाँ एक वोल्टेज लगा दिया हमने, और ये एक कांस्टेंट रेजिस्टेंस ले लेते हैं, और ये हमारा स्ट्रेन गेज हो गया। स्ट्रेन गेज मीन्स नथिंग बट योर वेरिएबल रेजिस्टेंस, और इसके अक्रॉस एक वोल्टेज ले लिया। कन्वर्ट हो गया? नहीं हुआ? सो ऑब्वियसली योर वी नॉट विल बी इक्वल टू your sensor resistance divided by sensor resistance plus your fixed resistance. और क्या होगा? और भी कुछ होगा?
रिप्लाई नहीं
हैं? वोल्टेज हो जाएगा ये जो सप्लाई किया आपने. So as the RS will vary, your V naught will vary. But although this ठीक है, it is fine to all of you.
यस सर
Yes,
So
sir.
this, हाँ बोलिए.
No, sir. Fine, fine.
So here, this is the easiest way, but it is not a best way. It is having many problems. This method of conversion is having many problems, but it is one of the easiest way and practical also. It's not like that it is we cannot use, but it is not a very good circuit. Anyway, so your sensor output is from here we are getting this voltage, and then this voltage, because when you are converting, when you are connecting it to A to D converter, so to have a good resolution, we require that voltage should vary between certain range, means like 0 to 5 volt or 0 to 10 volt. So if this voltage is not enough, although it will vary as this resistance will vary, but it is not enough to be interfaced with the A to D converter, then we require amplification also. So the next signal, so this is called these intermediate stages, whatever we are doing to make our signal suitable for the next stage, it is called signal conditioning. So one of the here in this case, after strain gauge, we are connecting this. So this voltage divider circuit, which basically converts the resistance into the voltage, is a signal conditioning circuit. Now your signal is not having required amplitude, then we will amplify it. We'll amplify it. So this is called amplification. This is another. You can say that signal conditioning step. This is another signal conditioning step. We amplify it. Now suppose after this your signal is having certain noise and it is not suitable to be converted in given to the A to D converter, then we require filter also. So all these things are whatever we are doing to condition the signal so that it should become and this is basically all the main signal. The signal is basically your sensor signal. This sensor signal we are conditioning so that it can be made suitable for the next stage. So this is called signal conditioning. And signal conditionings are many things, whatever you require to make signal suitable, and it is a part of all integral part of your instrumentation system. So this is I took one example. Now Wheatstone bridge is considered as uh, most means it is best signal conditioning circuit for resistive sensors, not only for a strain gauge but any resistive sensor. We had already studied in detail in first unit about the strain gauge, about the Wheatstone bridge, and at that time I told you that you should not means whatever resistance measurement method we were discussing in the first unit. I told you at that time it is not only used for measurement of constant static discrete resistance, but you should study keeping in mind that it is all these methods are used to measure the sensor resistance. So here we are applying the strain, we are using the strain gauge as a signal conditioning circuit for the resistive sensor, and in this case the resistive sensor is strain gauge. Now what exactly your Wheatstone bridge is doing to the strain gauge signal, I am asking to all of you. I described the stages and all. So what exactly, whatever stages, means signal conditioning stages are required for a strain gauge that I had described. What exactly is signal conditioning step it is doing? Your strain gauge, because here strain gauge is used as a signal conditioning circuit for strain gauge. Your Wheat-Wheatstone bridge is used as a signal conditioning circuit for strain gauge. So what exactly signal conditioning function it is performing? आप लोग तो बोलते ही नहीं हो यार, ये कर क्या रहा है, इसमें हो क्या रहा है?
सर जो एक एक्सटर्नल वोल्टेज हम लोगों ने सप्लाई किया है, तो स्ट्रेन गॉज की मतलब जो भी वैल्यू से वो ब्रिज जब ये हो जाएगा, बैलेंस हो जाएगा।
अच्छा, देखिए बेसिकली व्हीट स्टोन ब्रिज इज यूज फॉर मेजरमेंट ऑफ रेजिस्टेंस, है ना, यही करते हैं हम। ये सपोज अननोन रेजिस्टेंस है, तो इसमें क्या करते हैं कि वी मेक द ब्रिज बैलेंस, एंड व्हेन ब्रिज इज बैलेंस then obviously it will satisfy R1 upon R2 is equal to R3 upon RG, and if R1, R2, R3 is known, then we can measure RG. But in first unit I told you that in two different operational mode the Wheatstone bridge can be operated, can be used. One is null mode and another is deflection mode. Deflection mode कुछ याद है आपको? टेस्ट भी दिया आप लोगों ने, आपको नल मोड और डिफ्लेक्शन मोड पढ़ाया था मैंने फर्स्ट यूनिट में।
यस
Yes, sir, yes.
Here you see the bridge is used in deflection mode, and that too in voltage sensitive mode. Deflection mode is also of two kind, current sensitive and voltage sensitive. So here it is used in the voltage sensitive. Voltage sensitive means your detector is voltage sensitive. Voltage sensitive detectors are having very high input resistance. So here we are, it is open, so it is like your voltage sensitive. So here now, as I told you that because your resistance may change, your strain may be dynamic, so the resistance may change with time. So if we are using it in null mode, then it is not possible. If it is fastly changing, and then it is not possible to balance the bridge before the 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 strain value is changing to another value. So in that case we use it in deflection mode. So in deflection mode, initially your bridge is balanced. How can we make it balanced? So suppose when your strain gauge is, it is very interesting, please listen carefully and try to understand. If you are having any question, you can ask in between. So this strain gauge is, suppose initially when strain gauge is um, relaxed, in relaxed form, it is not subjected to a strain. So that at that time, if its resistance is 100 ohm, then we'll take the 300 ohm resistances and we'll connect it in the bridge configuration. So obviously your bridge will be balanced and this voltage will be zero. The potential difference across these two terminals will be zero, because both of the voltages will be at the same potential with respect to ground. So that's what I had written here. So this is called equal arm bridge. Here all the arm resistance are initially equal. Now when there is a strain, then obviously this resistance will change, and it will, your bridge will become unbalanced, and a voltage will appear here. A voltage will appear here. And as because there is no problem of requirement of balancing, so we can note down the voltage. So what exactly your bridge circuit is doing, it is doing the same thing whatever is done by the voltage divider circuit. Are you agree with it?
Yes, sir.
So basically the Wheatstone bridge we are using, when it is used as a voltage sensitive bridge in a deflection mode, then it converts the change in resistance in strain gauge or any other resistive sensor, not only strain gauge, any other strain sensor is. So when this resistance of the sensor will change, accordingly this voltage will change. And this is basically converting, this circuit is converting the change in resistance, strain gauge resistance, into voltage. Is it clear to all of you?
सर स्ट्रेन गेज की जैसे वो डायनेमिक रेजिस्टेंस जब भी डायनेमिकली चेंज करेगी तो उसी हिसाब से वो वी मेजरमेंट चेंज करेगी,
हाँ,
कांस्टेंट होगा।
वोल्टेज चेंज होगा उसके हिसाब से। ये जो वोल्टेज अक्रॉस द डिटेक्टर है ना, बिकॉज योर डिग्री ऑफ अनबैलेंस विल चेंज।
तो वो
इनिशियली
फ्लक्चुएट करता रहेगा।
इनिशियली वी कीप when strain is zero, so this voltage is zero. When a strain is zero, this voltage is zero. When there is a strain, obviously your resistance will change. This bridge will become unbalanced. Then we'll have some value for this voltage. So this voltage is proportional to the strain. Are you okay?
Yes.
Yes, sir.
ठीक है ना? So you can see that this circuit is doing the same thing whatever voltage divider circuit has done here, but this circuit is considered much better than this circuit, although both of them are contemporary. Both of them are contemporary as far as the signal conditioning function is concerned. But this Wheatstone bridge is, although complex in comparison to the voltage divider circuit, but it is much better. I'll keep on updating you why it is better whenever will. Anyway, now I'm concentrating to the bridge circuit. Now, as you can see that as the strain change, the resistance will change and this voltage will change. Now this voltage, if this voltage is in the required range as per the next stage, it is fine. We'll connect it to the next. Suppose this is your next stage. Suppose it is again A to D converter or something like that. So if it is of the suitable range, then we'll connect it. If it is not, then suppose the voltage amplitude is very small, because generally this is the practical situation. Generally you will find that the strain is also very small, so the change in resistance will also very small, and so the unbalance will be small and this voltage will be. So you are required to scale it, or you are required to amplify it. So we'll amplify it. In this case, actually, you can see that differential amplifiers are used. Differential amplifiers are used, this is connected through a resistance here, and this is connected through another resistance here with ठीक है। ये क्या सर्किट है, कोई बता सकता है? ऑपरेशनल एम्पलीफायर सर्किट्स तो पढ़े होंगे आपने।
Yes, sir.
ये किस चीज का सर्किट है बताओ? सबट्रैक्टर सर्किट है भाई। जो वोल्टेज यहां है और जो वोल्टेज यहां है, इससे ये वोल्टेज माइनस हो जाएगा और कुछ गेन होगा इसमें। सो ऑब्वियसली योर आउटपुट इज प्रोपोर्शनल टू, अगर ये सपोज V1 है और ये V2 है, तो आउटपुट विल बी प्रोपोर्शनल टू V1 minus V2. So when bridge is balanced, then output is 0, and when bridge is, and certain gain, obviously certain gain. gain is A. So when voltage bridge is balanced, so V1 minus V2 will be 0. V1 minus V2 will be 0. And when it is unbalanced, then proportionate amount of voltage will appear here. And if it is suitable range, then we'll connect it to the final stage. If it is still having some issues, imperfections, then suitable signal conditionings are required. So this is what although this is not the topic of discussion here as far as the topic we are discussing, but this is the larger picture. That's why I'm trying to make you understand. You should have this thing in your mind, that why we are doing all these things. So anyway, this is how our instrumentation systems are made, and what are the different parts, and what are their requirements, significant, all these things. I just gave you one example. Now I'm coming back to the Wheatstone bridge as a signal conditioning circuit for strain gauge. So still the story we are yet to start. So whatever I discussed here in this slide regarding the signal conditioning, if anybody is having any question regarding that, you can make it clear. आगे बढ़े भाई, आप लोग कुछ बोलते भी
Sir,
नहीं।
V1 minus V2 is proportional to the change in resistance or
यस,
the
करेक्ट करेक्ट।
कि सर ये मतलब सर फ्रैक्शनल चेंज इन रेजिस्टेंस।
देखो, change in resistance and fractional change in resistance, this is only matter of how you are um, means indicating, you wish to indicate your uh, resistance. देखो, fractional change का मतलब ये होता है, both the thing are same thing. Delta R is the change in resistance, but there is a way. Generally what we do, we don't take it in absolute terms, we take it in normalized terms. So we prefer that we take, because when you will compare delta R upon R, because of the comparison, it is more suitable. When you are taking delta R upon R, both are same thing. Both are, in this case, it is absolute terms, so it will be in ohms, and it is here it is in normalized terms, it is dimensionless. And so when we are basically comparing two variations, then we always prefer this one, because it will have same base, your R value will same for same strain gauge. So it is nothing, means these two things are not different, but they are same. They will have same kind of variation. Only thing, this is your normal, this is in normalized form, this is in absolute form. That's all. That is what is the difference. So whether your output is proportional to delta R or delta R upon R, it is the same thing.
Okay, sir. Thank you, sir.
Now, any other query? Now we are going to analyze this circuit, the Wheatstone bridge circuit, as a this Wheatstone bridge circuit, although it is considered as a best signal conditioning circuit for any resistive sensor, but for in case of strain gauge, it gives many advantages, many privileges. So it is just awesome as far as the means it gives additional advantages. Although it is, as I told you, it is best for any resistive sensor, but it is more than best for strain gauge. And why I am saying so, that I'll tell you. Now I'm going to analyze this circuit. So you had already studied this circuit in the first unit. So suppose the strain gauge is strain initially. Suppose initially all the resistances are same. And when your strain gauge is relaxed, then it is same. Then your bridge will be balanced, and your voltage across the detector arm will be, potential difference across the detector arm will be 0. Now suppose there is a change. Your strain gauge is strained. So there is a change in resistance R plus delta. The bridge will become unbalanced. The value of V means your voltage across the detector arm will be equal to Rg upon R2 plus Rg. ये वोल्टेज डिवाइडर बन रहा है बैलेंस. ये तो आपका वोल्टेज सेंसिटिव ब्रिज है, तो ये तो ओपन रहेगा. तो Rg अपॉन R2 प्लस Rg, क्योंकि ये दोनों पैरेलल हो गए, और ये जो वोल्टेज यहाँ आप अप्लाई कर रहे हैं, इट विल अपीयर अक्रॉस दीज टू. ये दोनों ब्रांचेस सीरीज में हो गई, ये भी दोनों ब्रांचेस सीरीज में हो गई. सो दिस इज Rg. ये वोल्टेज जो यहाँ होगा Rg upon R2 plus Rg into V, and here it will be R3 upon R1 plus R3 into V. That's what I had written and earlier also. Yeah, Rg upon V. Then then we are simplifying it, because this Rg is written as R plus delta R, and here you can see that all are R, so it is 1 by 2. So finally we are able to establish the relation between change in resistance through the strain gauge and your final response. अब आप अगर देखें इस पे, नाउ यू लुक इट केयरफुली. अभी तक जब हमारे पास सिर्फ स्ट्रेन गेज था, है ना, स्ट्रेन गेज है, तो हम स्ट्रेन दे रहे हैं एज अ इनपुट और रेजिस्टेंस आउटपुट मिल रहा है. ठीक है, ये आपका सेंसर है, स्ट्रेन गेज. वी आर गिविंग अ स्ट्रेन and we are getting resistance. ठीक है. Now this resistance is given into the bridge, that is your bridge circuit, signal conditioning circuit, and we are getting voltage. जी, बात समझ में आ रही है आपकी? Now we are having two stages. जी, बात समझ में आ रही कि नहीं आ रही?
Yes, sir. Yes.
Now obviously earlier this was the response, then we require to have a relation between, because we are not interested in measuring resistance or measuring voltage, we are interested in measuring this strain. So obviously we require a relation between, now a relation between voltage and final response, and this parameter which we are interested in measuring. So here whatever we are doing, we are trying to establish a relation between voltage and strain. That's what we are trying to do. ठीक है, ठीक है भाई, हाँ तो बोल दो भाई.
Yes, sir.
Okay. So here you can see that we are able to establish the relation not between the strain and voltage, but we are able to establish the relation between resistance and voltage. Is it fine? The output of the sensor and the voltage. Output of the sensor
Yes.
and the voltage here. So that's what we have done. Now we'll make certain approximations, because delta R generally in case of strain gauge is very small. So if this is true, then in denominator in comparison to R, we can neglect the delta R. So it will become this is very, this you had already, this particular expression you had already derived in case of voltage sensitive bridge earlier in the first unit. So we got that expression. Now one more stage will go back, because we are able to from here we reached here, means if you know the voltage with this expression, we can find out the delta R. Now we'll go to back to here. So obviously the relation which we have established for the strain gauge between R and strain, that will be used. So you know delta R upon R in case of strain gauge, delta R upon R, that is a fractional change in resistance or change in resistance, is equal to gauge factor
Time strain.
times strain. Is it fine to all of you? Now we'll replace here delta R by R by this expression. So finally we are able to find this final expression. So if you know for a particular setup, if you know these constants, obviously your strain should change, but other parameters that is present, other coefficients, other terms, it should be constant. So if the strain will change, your voltage will change. So by measuring this voltage, if you know these constants, you can find out the strain. This is how measurement system, instrumentation systems work, and this is how their input and response and input are basically related. So if you are having any comment, you can ask, please. Now I'll compare. You see, you got a expression for voltage divider and for a this particular expression I'm talking about for the in this case for the Wheatstone. In this case, even if your strain is zero, your output is not zero. Huh? Because suppose this is a 100 ohm strain gauge resistance when it is relaxed form, and this is another 100 ohm and this is 5 volt. So obviously 2.5 volt will appear here as the output when strain is zero. But here situation is not that. When strain is zero, then delta R will be zero and your output will be zero. So this is a desirable situation. When your parameter which you are measuring, it should be zero when that parameter is zero. But here in this case, in this circuit, this is not satisfied. Then this is called bias adjustment, offset adjustment. So in this case, we require a circuit to make it zero. We require a subtractor circuit here to make it zero. You understanding? So, and your Wheatstone bridge is providing, by default, it is providing that thing. Second thing, you see the variation in output voltage is not linear with the variation in strain gauge resistance, because this equation is not y is equal to mx plus c kind of equation, because your R is coming in the denominator also. Your R is coming in. So because of this, and we always want that the final response and the stimulus should have linear relation. Here in this case, you see this is satisfied. You are having y is equal to mx. Here you see, if you take delta R is varying, obviously your R is constant, your V by 4 is constant. So this is basically y is equal to mx type of equation. Means the variation will be straight line variation. So this is why it is why this linear relationship is required. That is not in your course. It helps tremendously in calibration basically. So here you can see that this circuit, your Wheatstone bridge circuit, by default it is providing the linear relationship between the final stimulus, the stimulus and the final output, whether it is intermediate or whether it is final. You can see with the strain also it is linear. So this is how this circuit is considered better and best in comparison to other circuit. Here I had shown you one of the primitive circuit, simplest circuit is called voltage divider. So if anybody is having any question regarding whatever we have discussed, here you can ask, please.
सर यहाँ जो सब्ट्रैक्टर सर्किट का यूज हुआ है वो सिर्फ एम्पलीफाई करने के लिए हुआ है ना, अगर स्मॉल स्ट्रेन रहा तो स्मॉल बी
हाँ, ये यहाँ पे जो हमने यूज किया है, इसको यूज किया है सब्ट्रैक्टर सर्किट एज अ differential amplifier. Differential amplifier is having huge application in measurement instrumentation. So this is we use as a differential amplifier. वही चाहिए हमको ना यहाँ. ये जो दो रेजिस्टेंस, जो दो वोल्टेजेस आ रहे हैं, इसको 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 माइनस होना चाहिए, दोनों का सब्ट्रैक्शन होना चाहिए। तो ये हमें एक डिफरेंशियल एम्पलीफायर चाहिए, तो वो इसको यूज किया हमने डिफरेंशियल एम्पलीफायर। वी कैन यूज, अब आपने कितना पढ़ा हमें नहीं मालूम, वी कैन यूज, although it is not considered as a good differential amplifier, but we can use it as a differential amplifier। ये differential amplifier की तरह काम करता है। अगर ये दो रेजिस्टेंस हम सेम ले लें, ये दोनों और ये दोनों R1 और ये सेम अगर ले लें, तो ये काम करता है एज अ डिफरेंशियल एम्पलीफायर। R1 जो आपका गेन यहाँ A दिखा रहे हैं, ये होगा A will be equal to R1 upon R। So by having a suitable value of R1 and R, we can get the required gain। बात समझ में आई?
Yes, sir.
ठीक है?
Yes, sir.
Any other question? Any other query? Now, this is one of the function that signal conditioning step, very important signal conditioning step, or you can say that whatever signal conditioning step this circuit is performing here, it is absolutely necessary for any resistive sensor or any passive sensor rather. Means if you are having a passive sensor like resistive sensor or capacitive sensor or inductive sensor, it is highly likely that you are required to convert the change in resistance, change in inductance, change in capacitance into the voltage. So this particular circuit is a converter circuit for resistive sensor, your Wheatstone bridge. So this is doing one. Now it, as I told you, that it is a wonderful circuit, and especially with the strain gauge, it performs many important signal conditioning steps. So another issue that I discussed, I told you that if this strain gauge is used for measurement of strain, for sensing the strain, then obviously whenever this voltage will change, we'll say that there is change in strain. Now, and with this formula we can calculate also what is the strain. Now if suppose you're putting it somewhere in the field, suppose to measure the strain of a flyover, and although strain is not changing, but there is a temperature change. So if it is made up of semiconducting material or even conducting material like platinum or any other material, stable material I'm talking about, it can be made for copper, from copper also. So because of the temperature also, its resistance will change. And obviously whenever there is a change in resistance because of any reason, whether it is because of the temperature or because of the strain, this voltage will change, and this voltage is finally calibrated in terms of, यहाँ एक मीटर लगा दिया आपने और उसको calibrate कर दिया in terms of strain, because every value of voltage corresponds to certain value of strain from this mapping. This is the final expression. So we don't want that. We always desire that we should have an instrumentation system which respond only to the parameter which we are interested in measuring, and it should not respond to any other parameter. But here in this case, you see your output, your response will change. In any case, whatever may be the case, if there is any change in resistance because of any reason, whether it is because of the strain or because of the temperature, your output will change. And we generally we don't want this should happen. And this is the pertinent situation in a strain gauge. This is the pertinent situation. This is a potential imperfection, you can say. So this means we require some signal conditioning circuit or some signal conditioning way to make our system insensitive to the temperature change and sensitive to the strain gauge. So this is you can see that Bridge offers another advantage, another feature, the required feature, that it can compensate the temperature. And this method is called, यार पड़ोस से ऐसी आवाज आ रही है
null method, no sir, zero deviation.
जी. This is dummy gauge method, and in this method I'll explain it. I'm just trying to give you the feature of what exactly we get out of it. This is strain gauge. We take, instead of one strain gauge, we take two strain gauges, and one strain gauge is active strain gauge. It is bonded to the structure, and another strain gauge is kept somewhere in the same vicinity, but although it is not bonded, so this is not active. And then we connect it in this bridge like this. Earlier we were having only one strain gauge, that was active strain gauge. Now we are putting another strain gauge here, so it won't affect whatever, means this system will also work the way this system was working, but it will give another advantage, that it won't, our output will not vary with the temperature. And how it is done, that I'll discuss on the next turn. I'm closing my discussion today here, and you respond your roll calls, and whatever queries you're having, we'll discuss that thing also on the next turn.